Okay, so sigma Fy equal, what does that mean?
Over here, we have sum of the forces in the y direction. Y direction's up and down. So we're looking at the sum of the forces up and downwards.
And what have we got for up and downwards?
We have, sorry,
right on
we
that
have
post,
50,
yeah.
75, 50 pounds downwards, 75 upwards, and the vertical component of GD.
Okay, let's slide that away.
Yep. So we have our negative 50 because it's downwards.
Good.
Positive 75 because it's upwards. And over here, if you recall from last time, we use sine for the sum of the forces in the y direction. Our angle is 45 degrees. So we take the sine of 45 degrees, plug everything in, we get negative 35.36 pounds is dg.
And negative means?
Means compression. So originally, we had the arrow pointing away because we assumed it was tension, just by convention.
Good.
Now that we know it's a negative amount, that means it's compression, it's going towards.
So that's what the other arrow is for.
Correct.
Okay, so now we know GD, we have GD and GF, what's left? CD.
CD, yep.
Okay, so slide the, get rid of that off there. There we go.
Yep. Now we look at the sum of the forces in the x direction. Very similar.
Well, here, let's go back to the diagram. So what's in the x direction?
We have CD, the horizontal component of GD, and GF.
Okay, so we got three.
Three components.
Let's see what we got here.
So, very similar to the sum of the forces in the y direction, except this time we use cosine because it's in the x direction.
Good.
Same thing, 45 degrees, so we take the cosine of 45 degrees, take FG, GF, and CD.
Okay, so FG is positive. Let's see where show me where FG is.
FG, right over here.
Okay, and it's now we're using the arrow, that arrow, so it's going, so in the x direction, let's see the...
Yep, so it might be a bit confusing because previously GF was negative, a negative value.
Right.
The reason why we're using positive is because on a Cartesian coordinate plane, on the x direction, things to the right are positive.
And in the y direction?
And in the y direction, upwards is positive.
Good.
The reason why well, if you look at it, originally it was going away from the joint. But now that we know it's compression, it's going to the right, so it's positive.
So GF is positive. What's the other one we got?
CD.
For FG, where's
Oh,
FG?
yeah, right over here.
FG. Oh, that's the one we just did. So FG is positive.
Yep.
And DG, where's DG?
Right over here.
And that's also positive because it's going
To the right.
to the right.
The horizontal component is going right.
And the last one is CD.
Which is going left, so it's negative.
Which is what we got here,
Yep.
minus CD.
So plug everything in that we know. Very simple algebra. We get CD is 100 pounds.
Positive,
Positive, yep.
which means,
It's tension.
okay, now get rid of all the posters for a minute.
Yep. So because there's two lines.
Well, first now look at CD is right there.
Right over here.
The string with the turnbuckle. And I knew it was in tension to begin with, that's why it's a string. If it was in compression, it would have to be a piece of wood. So CD is 100, but that actually takes care of both parts of the truss. So we got another, there we go. So the two of them together are 100 pounds, which means each one is 50.
So in total, when we apply a 150 pound load to the deck up here, that means that only 50 pounds are going through this line.
Exactly. Okay.